Okay, now one more. This is going to be a lot of math, and so it's going to go kind of quickly. So you might want to pause and go over it and check the steps if you're not too solid with the algebra. But I want to give you an example. I want to run through the equations that they use in the book, which you're going to need for some of these problems for constant acceleration. Now, there are a bunch of different variables. There are a lot more variables than before, than for the constant velocity that you have to keep track of. And what you're going to have to do when you do these problems is you have to figure out which variables you know and which ones you're trying to find. Here's a sort of a list of the variables that we're going to use in these problems. So you could have, a lot of these problems will give you an initial velocity, a final velocity. They might give you or ask you for the acceleration. If we have constant acceleration, then there's only going to be one value for that. They may also ask you about the time that it took for some change to happen. They may also ask you about the distance that was traveled when this thing happened. Okay? All these things are related, and I'm going to show you how they're related. They're basically all related by the definitions of these different of the acceleration and velocity. So let's first of all go back to the definition of acceleration. So we can write an equation for that right away. Change in velocity over change in time. So for constant, this is the definition of average acceleration. It's also the same as constant acceleration. If the acceleration is constant, then the average and the instantaneous are the same. You don't have to worry about whether it's average or instantaneous. Okay, if it's constant, there's only one value for A. Now delta V is the same thing as the V final minus the V initial. So anytime there's a change, we can just subtract the V final minus V initial. Delta T goes the same way. It's the final time minus the initial time. Now in most of these problems, they're not going to bother specifying final times and initial times as different. They're just going to give you delta T. And in the textbook often, they just skip this whole thing and instead of delta T, they just write T. So I'm just going to write VI over T, where we understand T is the time from the start to the finish. Okay. So here's an equation for A. Let me just write it again. A equals the final velocity minus the initial velocity. That's the same as the change in velocity over the time. All right. Now I can multiply. I'm not going to tell you why yet, but I'm going to multiply both sides of this equation by T. What happens if I do that? Well, let's try it. On the left-hand side, I'm going to multiply by T, so I get T times A. The right-hand side, I'm going to multiply by T, so I get VF equals minus VI over T times T. I better put this in parentheses because the T is multiplying the entire thing here. Now the T, the numerator, and the T in the denominator cancel out, and so then I can write this. Actually, the conventional way of writing this would be AT. People usually like to flip this around, so you'll see this in the book. AT equals VF minus VI. Now if I was given, now I can turn this into something useful. If I wanted to know what the final velocity is, they gave me the acceleration, the time, and the initial velocity, I'd want to solve for VF. How can I do that? Well, if I add VI to both sides of this equation, let's see what I get. If I add VI to the left-hand side of the equation, then I get VI plus AT. If I add VI to the right side of the equation, I get VF minus VI plus VI. So I added VI to both sides of the equation. The minus VI and plus VI cancel out. And so now I can ignore those and I have an equation for VF. So I'm going to put VF on the left-hand side. I can always flip the equation, make the equation backwards if I want. It doesn't change anything. So VF will be VI plus AT. So if you know the initial velocity, and you know the acceleration, and you know the time, then you know what the final. Then you can find out what the final velocity is. The initial final velocity is just the initial velocity plus the acceleration times the time. Now I can do exactly the same kind of, a very similar kind of manipulation to solve for VI, and I'm going to not write that whole thing out here, but it just involves. It would involve, if I take this equation and I subtract AT from both sides. So I subtracted AT from the right-hand side, then that would disappear. If I subtract AT from the left-hand side, I would get VF minus AT. So I'll just write that out. VF minus AT. So if you want to check that for yourself, take this equation here, subtract AT from both sides, and you should get this. Okay, now one more bit that we need to do, and I'm going to leave those three equations sitting down there. I'll make a little more room.